Okay, welcome back to this segment of our lesson. In our last segment, we had a look at using the tangent of the complementary angle, okay? And in this lesson, we're going to look at how to use the ratios to find the missing angle in a triangle, okay? Now, again, we are looking at finding angles. Now, we've already reviewed the three ratios. The easiest way to identify the ratios is to use the acronym, okay? Acronym SOHCAHTOA, okay? SOHCAHTOA. Now, what does SOHCAHTOA refer to? Okay, the three ratios. S for sine, opposite over hypotenuse. C for cosine, adjacent over hypotenuse. And T for tangent, opposite over adjacent. Okay? Now, how do we use these three ratios to find the missing angle in a triangle? Okay? Now, it is important that in a triangle, you are given two sides. Okay? Those two sides will help you identify the correct ratio to use when you are finding the angle. Okay? Let's have a look at a couple of examples so we can see how these ratios are used. Okay? Now, example number 1, for instance, we have a triangle here, all right, with theta in this corner, okay? Let's see. The hypotenuse will be 5, and the side which is opposite to theta is going to be 4, okay? Now, notice this is your opposite side. This is your hypotenuse, and this is your adjacent, okay? Now, there is no value given for adjacent, but there is a value given for opposite and hypotenuse. So, from the three ratios given, sine is the ratio that uses the opposite and the hypotenuse. So, that's the ratio you are going to use to find the value of theta. Okay? So, let's do this together. Sine theta is opposite over hypotenuse. Okay, theta is unknown. Sine theta, substitute your values. Opposite is 4 over 5. Okay, now at this point you will have to do the division. Okay, 4 divided by 5 is going to give you 0.8. Okay, so 0.8. Okay, now this is not the value of the angle. You are going to go to your trig tables. Okay, go to your trig tables, and from the tables, in the sine column, find the sine value of 0.8. Okay, the sine value of 0.8. So according to the tables, the sine value for 0.8 is, and there are two angles that are the possible answers. Let's put them up and see which one is the most correct. Okay, so sine theta, given a value of 0.8, we have sine 53, okay, which gives us an angle of a sine value of 0.7986 and sine 54 degrees, which gives us a value of 0.8090. Okay, now have a look at those two sine values. Which of them is closest to 0.8? Okay, for this question, the most correct is 0.8090. Okay, so theta would be equal to 54 degrees. Okay, so this angle here is equal to 54 degrees. Okay, now if we are using the cosine ratio, it is very similar to the sine ratio, but you would need the adjacent side and the hypotenuse in order to use the cosine ratio. Okay, being that it is similar to the sine ratio, we will not do an example for this, but we will have a look at the tangent ratio. Okay, the tangent ratio. So let's look at example number 2. Given another triangle, okay, this is theta, there's your right angle, okay, with sides 4 and 7, okay. Now, again, notice that your hypotenuse here is not given, but you have adjacent and opposite sides given. So we are using the tangent ratio to find the value of theta. Okay, so tan theta is equal to, opposite is 4 divided by adjacent, which is 7. Okay, so let's do the division here. 4 divided by 7. 4 is smaller than 7, so we will write 0 times 7 is 0. Bring down 4. Okay. 4 is still smaller, so we are going to put a decimal point here, add 0, and bring it down here. Okay. Now, 5 multiplied by 7 will give us 35. Okay. Subtract, we have 5 remaining. Okay. And because 5 is smaller, we're going to have to add another 0 and bring it down here. Okay. Now what number can we multiply by 7 to give us a number closest to 50? That number is 7. Okay. So 7 times 7 is 49. We have 1 remaining. Okay. Now, I can keep adding zeros, and this number will get longer and longer because this is what we call a non-terminating decimal. It will not end. It will continue going. So to make life easy, we are going to just bring our answer to 2 decimal places, and we will use that to help us find the angle. Okay? So theta is equal to 0.57. Okay? And here at this point, we are going to consult our tables. Okay? Go to the tangent column and find the tangent value closest to 0.7. That will give us the correct angle to use. Okay? Now, let's look at tan 0.57. Okay, tangent 0.57. We have, again, two possible answers. And that is 1029 degrees, which is equal to 0.5543, and 1030 degrees, which is equal to 0.5774. Okay? Now, from the two angles that are shown, which of these angles gives a tangent value closest to 0.57? If I were to round this off to the nearest two decimal places, now this would give me 0.55, and this one would be 0.58. Which is closer, 0.55 or 0.58? Okay, I think this is obvious. Theta would be 30 degrees. Okay, 30 degrees. So this angle here is equal to 30 degrees. Okay, so be very careful when you are identifying the correct angle. You must identify the angle which gives you the closest tangent value to what is in your answer up here. Okay? Now, you can do this with the sine ratio like we did here. You can use the cosine ratio, and you can use the tangent ratio to find the value of an angle. Okay? The only thing here is to be very careful when you are identifying the angle. The closest tangent value gives you the appropriate answer. Okay? Now, I hope you have found this interesting. Okay? Because in our next lesson, we are going to apply all that we have learned, all three ratios, and finding the angle, okay, to a practical application of angles of elevation and depression.